Have you ever looked at a graph and thought, wait a second, this thing is perfectly balanced like it's mirrored? Honestly, probably not, unless you're the kind of person who reads math equations for fun. No judgment, though. Well, what you're noticing is symmetry. And in math, symmetry isn't just pretty. It tells us something deep about how a function behaves. Before diving into formulas, let's take a moment to feel what symmetry looks like. First, here's a shape that's symmetric across the y-axis. Every point on the left has a mirror twin on the right. This is what we call even symmetry. Now look at this one. It twists through the origin. That's odd symmetry. These patterns are everywhere, from reflections in nature to physics. So now that we've seen how symmetry looks and feels, let's ask the real question. Can the formula of a function reveal whether it's symmetric? Time to find out. Let's begin with the most classic example of even symmetry, fx equals x squared. Let's look at the formula. F of x equals x squared. To test for even symmetry, we substitute negative x into the function and see what happens. So instead of f of x, we write f of negative x equals negative x squared. Now let's simplify that. Negative x times negative x is just positive x squared. So we get f of negative x equals x squared. That's exactly the same as f of x. So what does this mean? If f of negative x equals f of x for every x, the function is symmetric across the y-axis. It's even, and that's exactly what we've just proven. Don't worry if you didn't catch everything right away. That's totally normal. We're going to look at more examples. Let's take a look at this curve. It's the graph of f of x equals x cubed. Notice how it bends through the origin, and if you rotate it 180 degrees around the origin, it lines up perfectly with itself. That's the visual sign of odd symmetry. But let's prove it with math. Just like before, we'll substitute negative x into the function. So instead of f of x, we write f of negative x equals negative x cubed. Now here's a key idea. Raising a negative number to an odd power doesn't cancel the sign. It stays negative. So f of negative x equals negative x cubed. And that's exactly negative f of x. And that's the definition of an odd function. F of negative x equals negative f of x. So f of x equals x cubed is odd. Now here's a new curve. F of x equals x to the fourth minus 3 x squared. At first glance, it might look more complicated than before, but take a closer look at the shape. It's clearly symmetric across the y-axis. That's the sign of an even function. Let's prove it with math. We take our function, f of x equals x to the fourth minus 3x squared. Now we substitute negative x in place of x. F of negative x equals negative x to the fourth minus 3 times negative x squared. Now simplify each term. Raising a negative number to an even power makes it positive. So negative x to the fourth becomes just x to the fourth, and negative x squared becomes x squared. So we get f of negative x equals x to the fourth minus 3x squared, which is exactly the original function. That means f of negative x equals f of x. And that's the definition of an even function. So even if it looks more complex, this function is still even. Now let's look at a slightly trickier function. F of x equals x over 1 plus x squared. The graph still passes through the origin, but this time the curve bends in a more subtle way. It doesn't mirror across the y-axis. Instead, it rotates 180 degrees around the origin and lines up with itself. That's the mark of an odd function. Let's see if the algebra confirms it. Start with the original function, f of x equals x over 1 plus x squared. Now we substitute negative x, f of negative x equals negative x over 1 plus negative x squared. Let's simplify. The denominator becomes 1 plus x squared because squaring a negative number gives a positive result. Negative x times negative x equals positive x squared. So that part stays unchanged, but the numerator remains negative x. So we end up with f of negative x equals negative x over 1 plus x squared. And that is exactly the negative of the original function. Negative f of x. This matches the rule for odd functions. F of negative x equals negative f of x. So we've proved it. This one's odd too. And that's it. We've made it through the symmetry saga. Even or odd, visual or algebraic, now you've got the tools to spot it, check it, and understand it. See you in the next one.